CrewtonRamone'sHouseOfMath.com. Fooling around with Oscar. Gonna start just playing, figuring out angles and stuff like that. Yeah, hopefully. So I have a 5 block and a 10 block. Okay, so then here's my question. You have your protractor. I want you to make this a 30-degree angle, because if I know that at a 30-degree angle this becomes my special triangle. This is 1, this is 2, and this is, what was it again? Do you remember?
I thought that would be 3, 4, 5.
Oh, see, there you go. That's why we're doing this. 3, 4, 5 is not the same thing. I used to think that too, but it's not the same thing. Good. Already, see? Oh, look, we're going to start making discoveries all over the place. Okay, so here's what I know. Oscar, look over here for a second. Look, yes, you need to look at your computer screen. I can tell when you're not looking. You don't fool me. This is 1. This is 2. What does that have to be?
Square root of 3.
Square root of 3. Bingo. Okay, that's just Pythagorean theorem. I know. 3 squared, or square root of 3 squared is 3, plus 1 squared is 4. That, right? We're just talking about this triangle. Okay, so I know that this right here, and so this is when the student and I understand each other, and I'm not making much sense on video, but anyway. I know this right here has to be a 30-degree angle. In order for this to be a 1 to 2 relationship, it only happens when this is at 30 degrees. It only happens when that's at 60 degrees. So my question is, if you make this 30, of course if I make this 5, then this is 10, then this is of course 5 square roots of 3. Find me a block that's going to fit here and use your protractor. Let's see, is it going to be 5 square roots of 3 about 9? Well, that looks pretty good. Look at me. Oh wait, it might be a little longer than 9. Is that right? Is that going to be a 30-degree angle? Is 5 square roots of 3 the same thing as 9? Maybe I need a 10. Well, for sure it can't be 8. I know that, because that's too short. I could do that like that, but then these angles are going to change. Do you see what I'm saying? And then this isn't going to be 10 anymore. So that length's going to change.
It's about 8.5.
About 8.5? And it certainly isn't going to be 10. I know it's not going to be 10 because 10 is too long.
I'll actually use that
as a measuring stick. Yeah, that's a good idea. And then take your 30 degrees and figure out what's going on here. And then in a second we can take 3, 4, 5 and figure out what's going on. See, these blocks, they teach a whole lot more than just, right? Okay, so and then the other thing you can do is, you have a calculator handy?
I can go and get one.
Go get one. Punch square root of 3. Put 3, hit square root.
I'm using Wolfram Alpha.
Alright, fine. Use Wolfram Alpha then. I don't care. Take square root 3 to the negative, or to the 1/2. What do you get?
There's actually now a square root then.
Oh, okay, cool. So anyway, what is it? Tell me the square root of 3.
1.732050.
You used to know that. 1.73 what?
2050.
Let's just leave it right there. 1.732. Or excuse me, point. Wait a minute, what is it? It's 1.732.
1.73205080756887.
Okay, so let's just do 1.732 just to keep it simple. Then I gotta take that and multiply it 5 times. And that's gonna be this length right here. And what do you get? Can you see it's gonna be a little more than 8.5? Because I know 1.75 times is already going to be 8.5, and I got a 3.2 there to go with. So what is it going to be when I multiply 5 times that number?
This is being a bit annoying. So, x square root of 3 is...
What are you doing? I want square root of 3 5 times. So just multiply 1.732 times 5 and tell me the answer before I get old.
8.66.
You're gonna go with 8.66?
I know the full number is 8.660254037844.
There you go. Let's just go with 8.66. So your estimation that it was about 8.5 is pretty good, actually, isn't it? You're only off by 0.16. Okay, so in order for this to be a 30-degree angle, this needs to be about, this right here needs to be about 8.66. This is 10. This is 5, obviously. So 8.6, it's almost 9. Do you see what I'm getting at here? Now, I can change the angles and I can change the sides. And you said something about, well, isn't 3, 4, 5 the same thing? 3, 4, 5 is not the same thing. But you know what? Trying to calculate it is going to be a little difficult, except you've got Wolfram Alpha right there, and also Desmos will be handy, and a bunch of other things. But you can just stick into Wolfram Alpha the relationship, and it'll tell you the angle. Because remember, what's the definition of sine, for example?
What do you mean?
What do you mean, what do I mean? What's the definition of sine?
Opposite over hypotenuse.
Opposite over hypotenuse. This over that. So I know I can say sine of 30 degrees is the same thing as 5 over 10, and I know 5 over 10 is a half. So sine 30 is 1/2, right? So I can set problems up to figure out if I want to know sine of some angle, and then I know these two sides, this and this, I can figure out what the degree is. You see where I'm going? Okay. So let's do that. Let's find out what it is. And there is a way to go about it. If I did have, let me find one of these, and one of these, and one of these. I'm going to set this up so this is the hypotenuse, and this is 3, and this is 4, and this is 5. Well, now I need to know sine of some angle. I don't know what the angle is, but I know the relationship of opposite over the hypotenuse. What's my relationship about opposite over hypotenuse on this one?
3/5.
3 to 5. I could also do, looking from here, I could also say I know it's going to be the same thing. Tangent. What's the relationship? What's tangent?
Relationship?
The definition. I want the definition, man.
Opposite over adjacent.
Opposite over adjacent. So I know the opposite over the adjacent is 3 to 4 on that one. Right?
Yep.
Okay, but I don't know what x is. How do I figure that out? Well, I can use some mathematics to figure that out.
By the way, you put sine. Oh. What about the cosine?
Oh, what about the cosine?
It's 4/5.
Cosine x degrees would be, what's the definition of cosine? You're right, it's 4/5. So it would be adjacent over the hypotenuse. See how handy that comes in? Okay, these are all going to be the same thing. That angle should all be the same thing.
Yep.
So now here's what you're going to need to do to figure out the angle. If I know, you could actually, I bet you could put in the Wolfram Alpha just like that, and you could put cosine x equals 4/5, just for fun. I don't know if Wolfram Alpha will do it or not. I can't remember. And see if it'll tell you what the angle is. There's another way to do it. In order to use, like, say, Wolfram Alpha, or even a lot of calculators and so forth, you know, it'll be different on various depending on whether it's Texas Instruments or Casio or whoever the calculator you're using. But here is sine to the -1. So on Wolfram Alpha, it's this thing to the -1, and then you put in the relationship 3 to 5, and then what is that? See, if I know the sides, I know the angle. If I know the angle in a side, I know the other side, because it has to hook up. It can't be something else. Again, that's why we love the math. There's no wiggle room. So what is sine? So punch it in your Wolfram Alpha, since you got a tablet there. What'd you get?
36.87.
36.87 is correct. 36.87 is this angle, right? And then do the other ones. Do tangent to the -1 3/4. Do cosine to the -1 4/5. They should all be 36.87, about there. Let's compare and contrast and see if that's right.
And by the way, I'll correct the radians to make sure.
Okay. And then the other and see, then we can do more algebra and figure out more stuff. What if I know the angle and I don't know one of these, then I can put an x there and just solve for x, which you can do. I've been now to 2 little soirees, dinner party, lunch type things. Just so happens, apparently I attract engineers and math guys, right? But just so happens the guy sitting across from the table from me was an electrical engineer. And I always ask him, how often do you use algebra? You know what his response was?
What?
All the time. Right? He's an engineer. Especially when he's beginning a project or if they're trying to figure stuff out. Algebra, when they're looking at all the time. How often do you use calculus? Not as much. Although he said he knew lots of guys that use calculus a lot. But algebra, if you're working at McDonald's, dude, if you're working at the cash register at some retail outlet, you're not going to use much algebra. Probably not at all. You won't need it. But if you're going to be an engineer, if you're going to be an architect, if you're going to get into computer sciences, if you're going to do anything that makes you money, you're going to need algebra.
Yeah, although I do see a tiny variance.
Yes, there's going to be, exactly, it's not going to be precise on this one. You know, why is that?
It's correct to about 12 decimal places.
Right. 12 decimal places, that's a long, 10 places is already, you're out to millions. So 12, you're out to 100 millions. But you're right, at 12 decimal places, you can't get from here to say, Jupiter. You gotta be a little more accurate than that. So this one was 36.87. So is tan 3/4 still 36.87?
Wait, I now don't see the variance.
Well, at two decimal places, you're not going to see anything. We're only out to tenths, hundredths.
I thought there was one, but I don't think there is one anymore.
Not here. But they should all be the same.
Because I went out to 22 definitely.
And they're the same. You went out to 22 places. That's cool. All right, so 36.87. Right? And if I wanted to get really sloppy about it, I could just say, it's about 37 degrees. Right? But let's stay at least at 2 places. All right, so is cosine 4/5 still 36.87?
What?
Is cosine 4/5 still 36.87?
Yeah.
It better be. Right? Because it's the same angle. Otherwise our math has problems.
Correct to at least 22 decimal places.
There you go. Now we can get. But do you see that relationship? Okay. So now I can look over here and I can say, all right, I'm still fooling around. This is all fooling around with this. I should get rid of all this other stuff. Hold on a second. So 36.87, we can do it a couple of ways. We can say 36.87 plus 90 and take that away from 180. Or you could do the same thing, just punch it into Wolfram Alpha and figure out what that angle is. So if I'm looking from over here, what's the relationship going to be?
Which relationship?
Any relationship. Tell me something. I'm looking from this angle right here. My theta is right there. So say I took cosine, I don't know what that angle is, cosine x, right? But I do know what the relationship of the sides is. Do you see what I'm saying? Let's get rid of this stuff too. All these guys. So this was looking from 30, or this was looking from over here. This is the relationship of 3 to 5 from over here. Now I'm saying let's look from over here. So if I look from over here, we can do it again. Sine of that angle that I don't know, I'm going to do -1 to the relationship of, what's the relationship here? Well, if I do, looking from here, sine is opposite over, is 4/5. Right?
Huh?
Is that right?
I get that's 3.13 degrees.
So sine of 4/5 is, and you see that it's right. That there's a name for that, and we'll let you figure that out. You get what? 5/3.
That's 3.13 in degrees.
That's what it should be. Is that what you did you put that in and get that, or did you just do subtraction? Is my question.
What's it? What I did? I put that in.
You put sines and -1 for. Oh look, 53.13. Let's add 36.87 to that. What number do I come up with?
90.
90. They better add up to 90. Right? These two are 90 plus 90. Oh. Let us fool around with some other. Oh well, that's, you know what? Not yet. Let's keep playing with this one. How about cosine and tan again? We know the answers already, right? Do we have to even plug them in? We don't have to plug them in, because we know they're all going to wind up being 53.13, 53.13. But what is it? Cosine, looking from over here, is going to be what two numbers?
Cosine.
Ka!
What did you say?
Well, I want to know what two sides am I going to use to figure out cosine when I'm looking from over here?
From where?
From here.
3/5. It's 3/5.
It's going to be adjacent over hypotenuse, right? Ka. I don't even have to do the math, because I already know it's going to be 53.13. How about, what's the next one? Tangent.
The tangent is 3/4.
Are you sure? Because looking from over here, tangent was 3/4. Is it the same? I'm looking from over here.
4/3.
1 1/3. So the tangent of 1 1/3, punch that in just to make sure.
Huh?
So punch that in just to make sure. So you're telling me that tangent 4/3 is going to be 53.13. Has to be, doesn't it? Doesn't it?
Yeah.
Did you get 53.13?
It's computing.
Yeah. Takes a second.
53.13.
Absolutely, has to be. All right, so there it is. Now we know on a 3, 4, 5, this is not a special triangle. It is not 30, 60, 90. Right? Those angles are 36, 8, 7, 53, 1, 3, and 90.
Yeah.
You do this enough, you teach this enough, you'll know them by heart, because you know them just like the other ones. But now, let's not fool around with some 3, 4, 5. Let's play around with a different one. Oh, you could give me another Pythagorean triple. You could make up a triangle of your own. I don't care. Make me something. And then you're going to tell me the sides. You're going to tell me the angles. All right, so make me a different one.
Huh?
Wow, make me a different triangle. We did this one up. And we'll come back to this next week though, because like I said, if I don't know, now can you see that all I gotta be able to do is, let's say I have this, and I have all this other information. Or let's say I have all this other information, but I don't have this. Do you see how I can solve for it?
Mm-hmm.
Right? I really just have to solve for x. Right, same thing over here. If I don't know the angle, but I know there's two sides. And we can start fooling around. If I know sine, and I do know, that's supposed to be an n. If I do know 30 degrees, and I know that this is, this is an easy one to start off with. If I do know that this is 5, but I don't know what this is, now I know that it has to be, what does that number have to be?
Sine 30 degrees.
At 30 degrees, what's the relationship?
A half.
A half. So if that's 5, what does that have to be?
10.
Bam. Correctamundo. Has to be 10. Now, how do I set that thing up so that I can figure out what I gotta do? Same thing. If I have sine 30 degrees and I have x over this and I know that's 10, what does that have to be?
Where?
There.
X over 10?
Yeah, what does the x have to be?
5.
5. Has to be. Okay, so now I can set these things up and start being able to figure out, well, how do I solve for this stuff? Let's get rid of this stuff over here and let's get rid of this baby over here for a minute. How would I solve for this?
Solve for what?
For x, I would have to do this. On this one, I'm just going to I'm just going to say 10 times whatever sine 30 degrees is the same thing as x. Does that make sense?
Yep.
I just multiplied both sides by 10. You see that?
Yep.
What do I have to do here? This confuses a lot of kids. What do I have to do? Yeah, thinking. Can see you thinking. How do I isolate x so that x is all by itself?
5 is x.
What?
Sine 30 divided by 5 is x.
Sine 30 divided by 5 is x?
Yeah.
So if I take, right, because if I put divide by 5 over here and divide by 5, it's basically invert, right? You can cancel across those guys to get the 1.
Yeah.
Let's see if that works. And we'll find out in a second. So sine 30 divided by 5 is going to be the same thing as x. Now, in both of these cases, I know what my x should be. Over here, I should get 10. And over here, I should get 5, right?
Wait.
Wait for what?
It would be sine 30 over 5.
One more time?
Sine 30 over 5 would be 1 over x.
Would be the same thing as 1 over x. I like it. So then what? How about if I just want to find x? Wouldn't I just take 5 and divide it by sine 30 and get x?
Yep.
Shouldn't sine 30 divided by, or excuse me, shouldn't 5 divided by sine 30 be the same thing as 10? Well, let's find out. Go over to Wolfram Alpha, again, and put that in there.
What?
This. We'll start off with the easy one. 10 times sine 30 degrees. What's the answer? It better come up 5.
Well, the bottom one is correct because 10 times 0.5 is 5.
Well. Because what do we know about sine 30? That's why I like this good.
0.5.
We know that sine 30 is the same thing as 0.5. Right? Now, how do we set this one up so we get 10? Is 0.5 divided by 5 going to be 10?
What do you mean?
What do you mean? What do I mean? I just asked you. Is 0.5, I know this is also, sine 30 is also 0.5 there. Is 0.5 divided by 5 going to be 10? No. I have to do it the other way around. I have to do, just like you said, 5 divided by 0.5 is going to be the same thing as x. And certainly 5 divided by 0.5, it's going to go in there 10 times, isn't it? I just have to move the decimal place. Multiply by 10, isn't it? No, so now we can start figuring out, like I said, if I know that sine, and then you're going to see, used to be in any trig book and any book on geometry, trigonometry, you'd have the tables in the back. And it would tell you sine 30 is the same thing as 0.5. And then it would tell you sine 31 is the same thing as point blah blah blah. And then it would tell you sine 35 degrees, is this right?
Yep.
But now you're starting to see how you set these babies up.
Which one?
So if I know the degree and I know one side, I can figure out the other side of my problem. Here is opposite. So if I know this is 30 degrees and that's 5, then I know that this right there has got to be 10. Now, if I change this, I don't know, let's change it to 40 degrees. Well, now I got to know what the sine of 40 is. You understand?
Mm-hmm.
And if I do over here, I got to do sine 40. So what do I got to do? I can either look it up on a table. These have all been figured out for lots and lots of years. You don't have to do any math. And I can see that sine 40 degrees is what? You'd have to look it up. And then I'd say, look, I take 10, if I know that that one side's 10, but now this is 40, what does that side have to be? This is the opposite over the hypotenuse. So this is telling me that on this, let's draw a picture, I just said this is 40 right here now. And I know that this is 10, but I changed my degree angle. So now I want to know what that is. And the way I figure that out is that, well, I got to know what sine 40 degrees is first off. The other thing I could do is get my blocks out and play around. And I also want to go back to playing with blocks because we got off on a tangent. But with you, it's most students I wouldn't do this. But with him I can do it. But do you see what I'm saying? Is that now I know that angle. I know one side. I can figure out the other side. So I can take something like this, and then I need a protractor to figure out, to make up 40 degrees, and then I could take something like this, and then I could figure out, well, how high up is that got to be at 40? How high up? The other thing you can do is take a, oh, where do I have one? Is take a block like this, right? Pile some stuff up, like take a, take something like this, and then take this, and can start moving this baby around. We can start playing with the blocks and move this and figure out what's happening there. When you slide it, what happens to the different sides. But you can also do it with just your plain old blocks. But do you see what I'm saying? Do you see how powerful the algebra is? Do you see how powerful the mathematics is? All I have to know is what that angle is, how far this is, or how far that is, or how far that is, and I can start setting up and solving for the other variable. You see?
Yeah.
Okay, so here's what I want to do. I want to make some more right triangles and just fool around and figure out what has to happen. Do another one. I want you, okay, so we just did 3, 4, 5. Don't do something,
13.
do, what?
5, 12, 13.
5, 12, 13, all right, so you know a Pythagorean term. 5, 12. And this is why you want to start out with known problems. Known sides, known where it's known, and you can't fail when you know where you're going. Instead of just fooling around with, alright, so 5, 12, 13. What do you think it's going to be?
What do I think what's going to be?
The angles! I know that one's 90. What do you think this angle's going to be? What do you think that angle's going to be?
My estimate?
Yeah, just make an estimate.
My estimate is for the top one, 70.
And what do you think this one's going to be? Then, what does it have to be? About 20?
Yeah.
Alright, let's find out.
And I think then probably accurate to about between 5 and 10 percentage points.
Okay, excellent. Alright, anyway.
Percentage points, sorry.
Alright, so look over here. So I'm going to say from this angle over here, sine of that angle to the -1, opposite over hypotenuse. What is 5/13? How many degrees is that? You punching Wolfram Alpha? 22.62. I think you're pretty accurate to within about 10%. You're pretty close.
2%.
Yeah. Well, no. 2 is not 2% of 20. Anyway, it's fine.
I meant to green.
Oh, okay. Yeah. All right. So yeah, 22.62 is that angle. What's this one then? Let me use a different pen.
When I said percent, the green.
And you can take your protractor out and measure. But we can be even more accurate here. Right? So when you put your protractor on there, you should put that out and you should come out to about 22 and a half. I don't know how accurate you can be with your protractor. You certainly probably aren't going to get 22.62, but you could certainly get 22 with your protractor.
I can't really because it only says at intervals of 5.
Right. So you really got to estimate using that protractor. Right?
Yeah.
Can you imagine the ancients trying to build stuff with that device in your hand and not having this kind of mathematics? And can you imagine trying to do this without decimals? Can you imagine trying to do this with Roman numerals?
I can't.
Yep, but they did, and man, those guys were mathematicians, because I can't imagine trying to do it with Roman numerals. Oh my goodness. But do you see how incredible the Greeks and Romans were? Right? Those guys that did math, that's why those mathematicians were held in such high esteem, because they could do stuff like, and now we made it easy. And yet I have a populace that cannot, I mean, dude, the average student doesn't do well here. Whereas all students should be able to get this. Especially when we're doing base 10 mathematics and we've got all this stuff done. Anyway, tell me what it is in blue here. So now I want to know what that angle is, and we could do sine again. I could use sine, cosine, or tangent because I know all the sides here, but let's do sine -1. That would be opposite over hypotenuse. Now it's 12 over 13, right?
Yep.
Tell me, what is it? And again, like I said, we could just do math. We could just add 90 and subtract from 180 and we'd have it. But if you got a computer, you could do this. But the thing is, or with a calculator, the thing is you got to know your calculations are right. Because how many people, I know so many students that will punch a calculator. The answer is completely bogus. But they punch the calculator, so it must be right.
Nope.
Nope. So anyway, tell me the answer. We're out of time.
67.38.
And you are 100% correct. And that's, of course, when I add these two numbers together, do you see they got to add up to 90?
Yep.
And do you see how I can look like a genius by making an 8, making a 9, making a 9, making a 10?
Yep.
Right? Just applying my supremely simple subtraction principles. Except now instead of making 100, we're making a 90. Right?
Yep.
So again, this is an 8, this is a 9, this is a 9, this is a 10. Super fast and easy. How do kids have trouble with this? It hurts my heart. Okay, so then what's the last one?
What do you mean?
Tangent.
12, 13?
12. Wait a minute. Of this angle, yep, it's opposite. Can't be 13 because tangent doesn't have anything to do with the hypotenuse. There you go. And see, there it is again. Right? How could you make that error? When it's tangent, you know it can't have 13 in there. I can see where you could get these two flipped around maybe, but certainly 13 can't be part of tangent because 13 is the hypotenuse, and tangent doesn't have anything to do with hypotenuse. Now, for you, I give you, right, this is your first day of looking at this, but I mean, if you're a high school student, you're 16 years old, you've sat in class, how do you make that mistake?
Yeah.
And you see it all the time. They get confused about who's where and what to do and what, right? No way. All right, buddy. Our class is over for today. Crewton Ramone's House of Math.com for more.